Hello. Today I'd like to talk about potential difference in series and parallel circuits. Now, people do find... Hi. Today I'd like you to understand potential difference in series and parallel circuits. And there's just a couple of things I want you to remember. So firstly, potential difference, you'll keep on hearing that phrase, it's just the posh word for voltage. So you've all heard of volts, you've heard of voltage. Well, we're going to try and start using the word potential difference for it. Really, it's describing the change in energy as electricity goes through devices. Hi there. Today, I would like you to understand something called potential difference in series and parallel circuits. Now, potential difference is just the posh word for voltage. So I'm sure you've heard of voltage, you've heard about the mains being 240 volts or 9-volt batteries. So generally scientists talk about something called potential difference instead of voltage, but it is the same thing. Potential difference really describes the change in energy as electricity goes through various different devices. Now that's not quite true, there's a little bit more to it, but you can think of it as the change in energy. It's measured with a voltmeter. Quite straightforward that. And one key thing, when you're thinking about voltmeters, you've absolutely got to connect them in parallel, and that's because potential difference is a difference. It's a difference between two different places, and so you've got to look at two different places. You'll see how it's connected. So previously we saw that when you get bulbs connected in series like that, and you just add more and more, the brightness goes down and down. So I'd like to briefly look at that and how we'd measure it. So you could set up a circuit with one bulb there in black, and I'm measuring the voltage in position 1. I'm measuring the voltage, or the potential difference, of the voltmeter. And you can see the voltmeter is connected in two places. It's connected to the positive side of the batteries and the negative side of the batteries. That's how we get the difference. And this bulb here, again, it has a voltmeter on it, it's got a second voltmeter, and that is connected to the positive side and the negative side, so we can get a difference. Now if you set it up like that, you might get two values, something like that. For example, 4 volts and 4 volts. It's the same voltage in both places, which seems a little bit like the current thing. It seems a little bit like the current. When we looked at the current, it seems to be the same in all places, but that turns out not to be true. Because if I set up with two bulbs, I can measure the potential difference, the change in energy over the battery, and then I can measure the change over each of those bulbs. What I discover is the battery has got a potential difference of 4, meaning it picks up 4 little bits of energy, really. The electricity picks up 4 chunks of energy, or 4 joules of energy, but we call it voltage. And only 2 get dropped in that. You can imagine it like spending money. If you get given 4, you can go and spend 2 in one shop and 2 in the second. But then it's run out. After it's gone through that second bulb at voltmeter 3, there's no money left, there's no energy left, and all the electrons go back to the battery with 0 volts. Now, we also looked at parallel, adding things in parallel. Okay, if you remember, they keep their brightness, which is possibly a little bit unexpected, but it's the true. So keep that in mind. When we think about how we're going to set this up and what things are going to be, adding them in parallel does not change the brightness. So something to do with the voltage isn't quite what we expect. So firstly, over on the left I've got a series circuit just like before, and it's 4 volts and 4 volts. They pick up 4 volts in the battery, and then all the electrons drop off 4 volts in the bulb. Over on the right though, well, same batteries, they're going to pick up 4. How much is going to be dropped at voltmeter 2 and voltmeter 3? How much? Well, surprisingly, it's 4 in each. Now remember, we're not dealing with current. We're not talking about the number of electrons that are going through each bulb. We're talking about how much energy gets used up. Well, all the electrons are leaving the negative side. They're leaving the negative side of this battery, going along, and then some of them go along the first row, and they spend all four bits of voltage in the bulb, and then they return with nothing. Some of the electrons, though, go down the wire, and then they go through the second bulb, and they spend 4 volts of energy in the second bulb, and they return with 0. You can imagine electrons running around all day with little chunks of energy. You can imagine that, and I'm sort of using energy and voltage and a little bit interchangeably, and they're certainly similar. So you could say this electron is carrying 1 chunk of energy, and the posh way of saying that, we're saying this electron has a potential of 1 volt. You can say this electron is running around with 4 chunks of energy, and therefore it's got 5 volts and things. So potential difference is the difference in potential. It's the difference in this energy. It's the change in energy. So there we have an electron going through the battery, and it's coming out with a change. It's gone from 0 to 4. The potential difference there is 4. Here we can see that they're going in with 0, and the electrons are coming out with 2 bits. So we can say the change in energy, or the potential difference, is 2 volts. There, well actually, although they're going in with 2 and they're coming out with 0, we don't say minus 2 volts, we actually still just call it 2 volts. It's the difference. We don't tend to use negative voltages and stuff. Until another lesson when I tell you we do. But anyway, 2 volts. Potential difference there is 2 volts. And here you can get the message, can't you? 5 bits of energy going in, and then it's 5 bits coming out, 0 coming out, and therefore the potential difference is 5 volts. There, okay, in this bulb, well, there must be something else further down the line, because the electrons always return to the battery with 0, so there must be another device further on. Well, they're going in with 5, and they're coming out with 3, so therefore the potential difference is 2 volts. And here we can see, well, it looks to me like on the first one, 3 volts, and then the second one only seems to be losing 1 volt. So those two must be different bulbs. They must be different voltages. They must have different ratings. In some way or other, they're different, and different amounts of energy is being used. So the potential, or the energy, is gained in the cells. However much they get given, however much the electrons get given, they are going to spend it in the bulbs. They're going to use the whole lot up, and they're always going to get back to the battery with 0. And then they pick up more. So we can see here, this battery, they're picking up 4 volts. The potential difference is 4. At the first bulb, they're spending, well, it looks like they had 4, they come out with 2, it looks like they spent 2 volts. And here, they've used up another 2 volts, and they get back with 0. The little electron over there on the left has got 0 volts, gets back to the battery, and then it's going to pick up another 4. So that explains why bulbs get dimmer. The amount of electrons picked up is spent and shared amongst the bulbs, and so they get dimmer in a series circuit. So let's whiz through a few of these. Let's try and work out what they would be. We've got V1 at the top there is 6 volts, V2 would be, well, it's just going to be 6 volts. All of the voltage is going to get used up and burnt and turned into light energy in that first light, the only light. Here, well, it's going to be 4 volts. Okay, if in V2 you've got 3.5 volts, then V1 must also be 3.5 volts. They must pick up 4.5 volts. Notice always, these voltmeters are connected in parallel. They've got to go before and after the device. Right, a little bit trickier, but I'm sure you'll be fine. We've got V1 and 2 volts. So if V1 is 2 volts, they're picking up 2 volts. Then in each of the bulbs, they're going to use up 1 volt. If it was 5 volts up there, it's 2.5 in each of them. And V1, well, if V2 is 4 volts, well, assuming the two batteries are the same, then the other bulb will be also 4 volts, and therefore V1 must be 8. 4 is getting used up in each of the bulbs, so they must be picking up 8 in the battery. So this one here, V1 is 12 volts. Well, we know that when it gets back to the battery, it's going to have used all of those up. So V4, if you connect the voltmeter in parallel with the first and the second bulbs, V4 must also be 12 volts. Whatever gets picked up in the battery is going to get dropped in the bulbs. V2 and V3 must both be 6. Right, V2 is 4. Well, assuming they're the same bulbs, then V3 must also be 4. That means V1, the total picked up must be 8, and the total dropped in V4 must be also 8. If similar thing really, 3 volts V2 must be 3 volts, and then V1 and V4 must be 6 volts. Okay, so we can whiz through a whole load of these. What we really need to do is look at some parallel circuits. Have a little think to yourself, what would this one be? Well, V3 is going to be 9 volts, and each of the bulbs must be 3 volts. We're only measuring one of them. Must be 3 volts getting used up in each of the bulbs. V3, 3 volts. Right, so that means each bulb individually must be 1 volt, and V1 must be 3 volts. V1, V2 is 6 volts. So if each bulb's the same, it's going to be 6, 6 and 6, 18 volts in total across all 3 bulbs, so V1 and V3 must both be 18. So let's have a look at some parallel bulbs and connect up some voltmeters to those. So the bulbs themselves are in parallel, and remember, their brightness does not change. Whatever it is the first time, whatever the drop is over one bulb, it's going to have to be the same potential difference across all of them. So V1 is 4 volts. They're picking up 4 volts in the battery. So across V2, if the voltmeter is connected across the 2 bulbs, V2, that's also got to be 4 volts, and V3 has got to be 4 volts as well. If V2 is 5 volts, well, they're all going to be the same, aren't they? V3 is going to be 5 volts, V1 is going to be 5 volts. Every single electron leaving that battery with 5 bits of energy, or 5 volts, is going to get to the things. They're going to return with 0. They've got a choice of ways to go, but either way they're going to drop 5 volts. V1, 12 volts. Okay, so whichever path they take, whichever path the electrons take, they're going to drop a total of 12 volts. So that means in each bulb they're going to drop 6. If they go on the middle row, 6 volts. If they go on the bottom row, they're going to drop 6 volts in each bulb. Right, V2 is 4. Well, V3 must be 4. But it suggests that on each row, on each branch of that parallel circuit, there's a total of 8 volts being dropped. So therefore the battery is going to be 8 volts. V3 is 1 volt, so it's going to be a similar situation. Each bulb is 1 volt, so each branch, each path is going to be 2 volts, and the battery must also be 2 volts. V1. Okay, V1's 12. Now that tells us, oh, this is a bit more tricky. Just be careful. V1 is 12 volts. Across each branch, or each path, they're going to drop 12 volts. They're going to go in with 12 and they come out with 0. Well, looking at the middle row there, There's 3 bulbs. That suggests they're going to drop 4 volts on each. Each bulb is going to drop 4 volts. So therefore, V2 is going to say 4 volts. On the bottom row, there's going to be a total of 12 volts dropped. And that suggests the electrons are going to spend 6 volts in each. Similar situation, V1 is 6 volts. Okay, so the middle row, 6 divided 3 is going to be 2 volts. And the bottom row, 6 volts divided by 2 is going to be 3 volts. V2 is 4. So if V2 is 4, well, there's 3 bulbs, so it must be a total of 12 volts across that middle row. On the bottom row, it's got to be 12 dropped. It's got to be 12 dropped, so therefore each of them is going to be 6. V1. Right, V2 is 2 volts. There's 3 of them on that middle row, so the total voltage being dropped must be 6. So the battery must be 6. V3, well, we know the total dropped across that bottom row is 6 volts, so it must be 3 volts in each. So I'm sure you're getting good at these now. V3 is 12, there's another one there, so it's got to be 24 across that bottom row, so the battery must also be 24. The middle row, there's 3 bulbs, so it's got to be 24, but with 3 bulbs dropping, 24 divided by 3 is 8 volts on each. So, the key facts to remember. Potential difference is the posh word for voltage. Potential difference describes the change in energy as electricity goes through devices. And if you want to be really pedantic, it's not quite that. You may go on to say otherwise, but it is roughly that. It's measured with a voltmeter. The voltmeter must be connected in parallel. Any potential gained in the cells has got to be spent in the bulbs. It's all got to go. The electrons always get back to the battery with 0 potential difference, which is very different to the current.